Let me introduce myself. Right, this is my second talk for the day. It's the relaxed one. I'm Sokratis Vidros. I'm the VP of Engineering at Clerk. We are an authentication solution for React and Next.js application. In my previous super lightning talk, I've demonstrated how to add an authentication in Next.js in 4 minutes. And right now, we're going to basically see what it takes in order to be able to do that in modern frameworks. You can check our site at clerk.com. We're hiring, so please have a look at the openings if you're interested. So it all began in the 90s. And in the 90s, smartwatches looked like this. And for those of you who are happy enough to be born in the 90s, I used to love these little things. Right now, we have an Apple Watch. JavaScript was invented in 1992. It was used in Netscape. It was the go-to browser back then. It was basically Mark Andreessen, who is, from the famous Andreessen VC, who was the founder of Netscape, and saw the need for interaction in the DOM. Like the websites were static, and he projected that we need something more dynamic. We need to be able to change things, add animations, submit forms, etc. So JavaScript looked like this. Event-driven programming, on click, you do something. That was pretty much it, basically, for around 10 years. Microsoft adopted JavaScript with Internet Explorer back then. And essentially what happened is that things remained pretty stagnant. Like front-end development was not a thing for about 10 years. Things changed. Actually, I think it was around 2005 when Mozilla came in, and they proposed Ajax. Right now, we just call it the Fetch API. And the other thing they did is that it was a renaissance of JavaScript that led to libraries like this. I mean, I'm sure of you know jQuery. Everyone who's using jQuery today is being booped in the best-case scenario. However, it's still in 81% of the most popular websites. So that's surprising. I mean, jQuery is still here and will remain with us. The good thing that jQuery did was, in essence, introduce the first way to ship libraries. And that was a jQuery plugin. I'm sure most of you have already written an autocomplete or a dropdown or stuff like that. The problem with jQuery, of course, was that everything was on a global namespace. It was the $sign. We used to load things from CDNs or from script tags, and that was the main way to deliver our code. The global object is a bit problematic, as you know. There's no true dependency injection. You had to load the scripts in a specific order, and you had to do it yourself. And of course, you pollute the global namespace. So what if jQuery used the $, and then Sokratis library used also the $? The last one will override the first one. So then we ended up in the immediately invoked function expressions, IIFE, that kind of solved this problem. It's basically this pattern I'm sure you're all familiar with, and solves the global namespace pollution problem. So then we started wrapping the libraries with this. So after 2 or 3 years, we started discussing about, OK, shall we move JavaScript to the server? And of course, Node came in 2009. And it became very, very, very popular, as you know. And Node also brought CommonJS. CommonJS was, let's say, a standard module system at the time. It was mostly used for the server, but it allowed us to module our code in a much nicer way. So we could have a very well-organized code on the back end and then used in the browser. The good thing is that it was very easy to use. You could just require. There's no need for docs. I mean, you just require things using their path, and it just works. It was built in, and order doesn't matter, and can detect cyclic dependencies. The problem was it was synchronous. There's one file per module, and it wasn't supported in the browser. It still is not supported in the browser. You cannot require things in the browser. But most importantly, for lib authors like us, it's not recyclable. So all the code will end up in the final bundle, no matter if you're just using a very small part of the library. Then we had things like this. I mean, how many of you know this logo? Cool. What's this logo? Browserify, correct. So then we had Browserify, and of course, Webpack. And basically, these tools became popular because they allowed to use CommonJS in the browser. How they did that? They just compiled the code in a big chunk, a bundle, so you could have multiple source files in development and one big chunk in the browser. The other thing that they did at the time is that they introduced what we call the universal module definition, and the name universal sounds very, very promising, because in essence you could just write your code in this closure, and it would work with all the popular module system of the time, like CommonJS, Browser Globals, or AMD. A lot of people still think, by the way, that UMD belongs to the past, but this is how the React 18.0, it's not the latest one, but it's the latest major React version, looks like today. So as you can see, the pattern is still here, and it's still used by most library vendors. So all of us were very happy. We're like, OK, we have UMD, universal sounds promising. Now the only thing we have to care about, we need to code like crazy, and the only thing we have to care about is this guy here, browser compatibilities, and basically make IE happy. In 2015, we had the first not universal, sorry, it's a bad word. We had the first suggestion for ESM modules. That was basically JavaScript module system that works both on the server and the client. So as you can see, this is export-import syntax that we all use today. It can work both on the server and can work both in the client. And why did we need this? We had CommonJS. We need this because it's standardized. CommonJS was built for the server. This works in both the server and the client. It's static, so it means that I can figure out the dependencies without having to run the whole code. It's not dynamic as CommonJS was. It can import CJS libraries, but CJS cannot import ESM, so this helps a lot with adoption. And of course, and most importantly for library owners, it supports reshaking. So for example, in our library, Clerk, we export around 8 authentication components. You might just need to sign in. You don't have to download all the library. The problem is that ESM introduced a new set of tools, Bubble, and TS, TypeScript, of course. I mean, TypeScript was introduced in general, but a lot of people opted for TypeScript at the time because it was a good way to get latest JavaScript features. So today, we don't have Candy watches anymore. We have Apple watches. And the question is, can we build our package for all module systems and have backwards compatibility with all runtimes? Because no one can guarantee that everything runs in ESM. So this is a packagation. It's the simplest packagation you can get. It has the name, the version. It has the main file. It's the entry point. The entry point means the first file that the library will load when it's required or imported. The types key is for types, for TypeScript. And on the type, so when it's types in plural and type in singular, on the type key, you can specify it's a CommonJS or a module or an ESM module package. So the question is, OK, how can I do both? Packagation now supports what we call conditional exports. It's, let's say, a subtype of a greater category of things that's called subpath exports. And this is basically, when it's present, it overrides the main behavior of the packagation. And you can export, you can basically specify entry points per module system. So as you can see, there is import and require, and each one has a different entry point. So the question is, should we build for both? Should we build for one? Should we build for the other? Actually, I don't have a definite answer, and I wish I had. In Clerk, we've struggled a lot with this. And we're trying to build for both and support as many runtimes as possible. The problem is that the build pipeline is very, very complicated. And we also have something that's called the dual package hazard. So essentially, that means that if the dist file of your package has both a CJS and an ESM version, it might be accidentally required or imported by both. So that ends up in 2 instances of the same library in the same application. And that's a very tricky and nasty bug. The other thing is default exports. There's a lot of bad stories around default exports and bundlers. In Bubble, I think you still need to configure something in order for export defaults to work in ESM. Same applies in ESBuild or LWC from Vercel. My personal advice is don't use default exports, prefer named exports. It's much easier to basically make your library work across all systems. So let's say that we solved the module system compatibilities, and now we have another topic, modern JS runtimes. Well, so what's a JS runtime? It's basically the engine, the JavaScript engine, and the APIs, the native APIs that surround it. The most popular one is V8. I'm sure you're all familiar with V8. You use it every day. V8 is in Chrome. It's also in the Chromium browser. It's also in Microsoft Edge. And we've been using that, the engine in the browser for more than 20 years now. V8 is also in the server. And in fact, it powers Node. So we're all very familiar with that. Recently, V8 is also at Edge, and it sounds very cool. I mean, the Edge it sounds edgy. So what does it mean? Right now, we have Cloudflare workers. We have Deno. We have Alibaba ER. I think it stands for Edge routines or something like that. So in essence, that means I can run JavaScript on the CDN. I can be as close as possible to my customers. OK, so a lot of runtimes on the server. As you can see, I demonstrated 3 V8 runtimes in the client and 4 already on the server. And I'm sure there are way more. I just used the most popular ones. So it looks like we're going to have the same problem with Internet Explorer all over again, but this time on the server, not on the client. The truth is that things are a bit better this time because I think we've learned from the mistakes of the past. There is this new working group called WinterCG. It stands for Web Interoperable Runtimes Community Group. And basically what they're trying to do is that they're trying to standardize some APIs across all runtimes. This is the draft that they have for Minimum Common Web Platform API. They're also working a lot with Fetch. Fetch started from the browser, moved in Node via Node Fetch package that has around, I don't know, 5 million downloads on a daily basis, although the implementation is not the same. Now at Edge, there is another implementation that's very close to the browser, but this working group is trying basically to propose a new implementation that's going to rule them all, and they're going to change the initial proposal by WG. Another thing, of course, is web crypto. We are in authentication space, so we care a lot about these things. We want to add, the group wants to add stream support for web crypto functions. And of course, there are way more APIs that still need to be adopted, but there is a lot of work happening as we speak in the area. So again, new question, new challenges. Can we build our packages for all runtimes? Yes, we can. I mean, at the end of the day, it's just JavaScript, right? It's the same language, both on the server and the client. And that's one of the best things around JavaScript. Like, it's very hard not to find a job. But joking aside, you can use the same tech across your whole stack with the same expertise and basically be very, very successful about it. So we're going to need something like an adapter pattern. And how does the adapter pattern look like in a package.json? It's a new feature that's called subpath imports. In fact, this feature has been around since Node 14, but to be honest, I found out about this feature 6 months ago. So the idea is that you import, basically you create an internal alias. It starts with a hash symbol. And then you specify a set of keys depending on the runtime. And is the contrast not enough? Yeah. Anyway, it will have a bit better. Sorry for that. So basically, you specify a list of keys, and you specify the entry points based on the runtime. For example, in the browser, I don't need to do anything about fetch. Why? Because it's already there. It's already on the global object. In Node, I need to polyfill. A good way to explain that is basically you can create a folder called runtime, one folder per each runtime, one for the browser, one for the Node, in this particular example. In the browser, you just export fetch. In Node, we require a polyfill from Node fetch native. And then the only thing we have to do is basically group all this together into an index file. The keys you saw there are actually keys that are proposed by the WinterCG group. So, for example, as you can see, in our example, the code on the left comes from the Clerk open source library. On the right, as you can see, we have way more vendors. Alibaba, Cloudflare, Deno, Meta, Netlify, Vercel, of course, BAN. So in essence, that means that you can specify one entry point for every vendor. And this drives to a new trend, let's say, that's called framework-specific infrastructure. So before that, we used to write Node, and then we can write Node in a container. We could deploy it in Netlify. We could deploy it in Heroku. We could deploy it in Vercel. Right now, things are becoming more platform-specific. So this is another interesting term. So many of you might wonder, do I need to know all this stuff? Actually, you're already using them, and they are in very cutting-edge features or frameworks. For example, React Server Components relies on them. React was a client framework. Right now, it's on the server. Next.js 13 App Router, the demo I saw it before, relies 100% on React Server Components. So under the hood, we do use this kind of technique. Remix selling point was basically one framework across every runtime. So you can run Remix in Cloudflare Workers, on Deno, on Node. So again, the concept is still there. Cloudflare HTML rewriter, it's one of my favorite things about Cloudflare. It's a new API they're proposing for Cloudflare Workers to rewrite your HTML as a network interceptor. Isomorphic authentication, that's basically what we do in Clerk. I demonstrated that earlier in the morning, but our solution can run at Edge or in Node and in the browser at the same time, and we have one package to rule them all. Of course, the use cases are way, way more, and as you can see, there's a lot of work happening by the community. Like, a lot of big companies are already involved, Cloudflare, Deno, Bloomberg. I also saw this tweet, the one on the bottom right. It was about, what's the name? It was LangChain.js. It's the ChatGPT GDP framework in JS, and we want to use it in JavaScript, and it has to be interoperable. So what I want to say, what I want you to keep from this talk is basically there's millions of NPM packages out there, and not all of them, I mean, the majority of them are still Node-focused, so there's a lot of work in order to port this functionality across all runtimes. And the runtimes that we're now using will evolve, and eventually we'll have better performance and better developer experience. That's all. Thank you very much. I'm Sokratis, and thanks for attending.